My name is Laura Jackson, and this is my exam 3. For question 1, we are asked, what is the standard deviation for the sample sum distribution? And we need to use the central limit theorem for sums. For this question, I used sigma equals sigma sub x times the square root of n, and I plugged in 25 and 75 into the needed values, and I got 216.506, and rounded that is 216.51, so we would select B, 216.51. For question 2, we need to find the probability that the means is more than 25.4 characters. So what I did was I determined the values for mean, the standard deviation, n, and x bar. I determined that 40 is greater than 30, so we can use the central limit theorem. And first I wanted to solve for the z-score, and I plugged in 25.4 minus 26 over 5 divided by the square root of 40, and that came out to negative 0.758, and rounded that was negative 0.76. And then I wanted to find the probability that the value of x bar is greater than 25.4. I would take 1 minus the probability, and that came out to 0.7764, and rounded that was 0.776, or 77.6%. So the answer is E, 0.776. Also in the z-score chart, that was negative 0.7 with the 0.06, and so the value was 0.2236. For question 3, we need to identify the amount of people that separates the 12.5% from the means of the population with bachelor degrees from the highest 87.5% in a sampling distribution of 25 states. For this, I identified the mean of 5 million, the standard deviation of 450,000, and n is 25. First, I wanted to find the standard deviation for the sample mean, and that was sigma over the square root of n. So I took the 450,000 over the square root of 25 and got 90,000. The z-score was found to be 0.125. And then I solved for x bar, which was negative 1.15 equals X bar minus 5 million. And what I needed to do, minus 5 million over 90,000. And what I needed to do was isolate X bar so that we could solve for it. And by multiplying this side by 90,000 and this side by 90,000, we eliminate the 90,000 on the right side. And we get negative 103,500 equals X bar minus 5 million. And we need to continue eliminating. So we would add 5 million to this side and 5 million to the other side. And we get a value of 4,896,500 is equal to X bar. And that was the answer that I got for that. So my z-score was negative 1.15, and X bar was 4,896,500. For question 4, we needed to first calculate the test statistic for this example and round our answers to 2 decimal places. And what I did was I entered all of these values into list 1, list 2, and list 3 in my calculator. And I used the ANOVA function to find that the test statistic was 2.794310768, rounded to 2.79. So that is my test statistic, 2.79. And then we needed to find the p-value, which was also calculated at that same time. And I got 0.0877, and rounded that is 0.09. For question 5, we needed to identify the degree of freedom and the critical values. And the degree of freedom is n minus 1, which was 20 minus 1, and that's 19. And the critical value, because we are finding it at the 0.05 level of significance, that would be this value right here. I found it to be 1.729, so my critical value was 1.729. For question 6, we need to determine the null hypothesis. And what I did was I began with finding the degrees of freedom, which was 23 minus 1. I got 22. And we were finding at the 0.10 significance level. So the hypothesis that I got, the null was the mean is equal to 6, and the alternative hypothesis, the mean is greater than 6. So for the degree of freedom in the chart, we find 22. And the critical value of 0.10, we find that it's 1.321. And in this shaded area, this is the 1.321, which is the rejection zone. 1.86 is greater than 1.321. So for that, we would reject the null. And there is strong evidence to conclude that the average number of hours of sleep per night for adults is greater than the recommended 6 hours. Then for question 7, we need to find a 95% confidence interval estimate for the population mean using the student's t-distribution. For this, I found the degrees of freedom, which was n minus 1 equals 38 minus 1, which is 37. So there's 37 degrees of freedom. And then the confidence interval estimate, we needed to find the tails of the test. So it was 1 minus the confidence level over 2, which came out to 0.025. So in the chart, we find that the 37 degrees of freedom with 0.025 is 2.026. So I found my answer of 2.026, and the correct expression was 6 over the square root of 38. So my answer was D. 51.03 and 54.97 with a margin of error equal to 2.026 times 6 over the square root of 38.